welcome to, I'm not sure which lab this is. This is Chem 75, right? 75?
Mm-hmm.
And we're looking at what is the title of the thing?
This is the relative mass of three gases.
Relative masses of equal volumes of three gases. We talked about this at the start of Chem 75, don't we?
Yes,
sort of physical properties of different substances.
You sure do.
And so this lab here, we're sort of going back a little bit in time, talking about physical properties of substances. And specifically today, we get to do gases, right?
Mm-hmm.
So have you ever tried to weigh a gas? You have.
Oh,
but I'm asking these people, not sure if we've ever tried to weigh a gas. And how would you go about weighing a gas? And how would you go about figuring out the volume of a gas? Two very good questions, which you will solve for us today, correct?
Correct.
All right, which would you like to start with?
Let's start with how to first of all, how to capture the gas.
Oh, okay.
Okay.
Now, what kind of gas?
We're probably going to start with oxygen gas first.
Oh, okay.
So what you're going to do, first of all, you don't need gloves. And you
no gloves.
Don't need glasses for this.
And no glasses. Well, I need glasses to see, though.
You need glasses to see. But for the most part, this is fairly safe. You're going to be dealing with tap water and rubber stopper, eyedroppers, bags, and gas. Okay, oxygen, carbon dioxide, and helium gases that generally we find in a lot of places that really aren't going to harm us. So you don't need gloves, you don't need glasses. So it's kind of nice, this lab, that way. Okay, still, please don't wear contact lenses into the lab. It's just unsafe.
Who knows who's been here before us?
Exactly. So if you rub your eyes or whatever, make sure you wash your hands after as well.
Right.
But you're going to obtain a plastic bag from the back. These plastic bags are the ideal plastic bags. They're kind of like sandwich bags folded in.
How much do they cost?
They cost about $1,000. So be careful with them. Okay, and what you're going to do is you're going to take a rubber stopper with a hole in the top, and these have been pre-done for you. You don't have to drill the holes. You don't have to put the groove in. And you're going to take and pleat the bag around the outside of the rubber stopper. Okay, just like so.
Very pretty.
Double wrap your elastic. Actually, let's do that a different way.
And make sure you still have a little bit of plastic up above. Yeah,
a little bit of plastic above. But you want as much volume as possible. This lab is a lot easier if you use the greater volumes. Okay, so you want to be fairly generous with the volume. So you're going to end up with something that looks a lot like that. Then you're going to take,
pretty.
Yeah, you're going to take your eyedropper. Now it's important that you remove the cap from the eyedropper before you do this. You also might want to just wet the end of it just a little bit before you stick the eyedropper into the hole of the rubber stopper, and then you're going to place your cap back on.
How far should I stick it in?
Just until it's in there sturdy. You don't want to push it in too far, and you want to push it straight in. Okay, lots of people will push it on the side, and because we're not wearing gloves, there has been one incident where a person pushed an eyedropper through their wrist. So just be careful.
Ooh, typically a bad thing.
Yeah.
Blood on that day.
Yeah, he wasn't very happy. Okay, and then you're going to replace the top of your eyedropper. So you have an apparatus that looks something like this.
Beautiful, beautiful.
Okay, once you've done that, it's really important that you get an accurate weight for this apparatus. So you're going to take it over to the orange scale on the side, okay, and you have to weigh this with a little bit of tilt or else the bag will obviously move away. So you want to fold it up.
Scrunch it up.
Scrunch it up, place it on the scale, and we have a weight of 27.7 grams.
27.7, okay.
27.7 grams. So that's pretty good.
All right.
About what it should be. Okay, from there, what you're going to do is you're going to go to the back, to the chemical storage, and we have 3 large cylinders there filled with carbon dioxide, oxygen, and helium. Okay, starting with the oxygen, you're going to take a sample of each of those 3 gases. Now, it's important.
Oh, sorry.
Oh, that's okay. It's really important that your bag remains at the same volume because you're measuring relative volumes. So they have to be the same all the time. So it's really important that your bag stays the same. When you go back there, you're going to uncork your bag and hand it to the technician. The technician will fill it for you until it's right full. It has to be at least this full.
Oh, I didn't really make that full.
That's okay. We'll make it a little fuller. Don't do that in your lab. Okay, it has to be at least this full when you're done. So at least that full. Now,
so you go to the technician, they fill it up with oxygen, then
then carbon dioxide, then helium last. Now, different gases will escape from this when you equalize the pressure. And what I mean by equalizing the pressure is before you put your cap back on, you're going to wait 3 seconds. So you're going to count to 3. You fill the bag up with air. I'll do this again. Wait till 3, 1, 2, 3, and then recap your bag. And what that does is it equalizes the pressure inside and outside so that this is an actual volume, not an expanded volume.
Now, you said you were using helium. Won't helium escape on us pretty quick?
It will.
So what do I do with that?
Well, what you're going to do is for the first trial with the oxygen, when you're waiting your 3 seconds, you're going to hold the bag sideways like this.
Oxygen sideways.
Oxygen sideways. With the helium, you're going to hold it up and down, so the helium will rise and stay in the bag. And for the carbon dioxide, you're going to hold it with the bag facing down because the carbon dioxide actually is more dense and it'll sink.
Hold it down. 1, 2, 3. Lid on.
Lid on.
I'm with
exactly. Okay. So, and after that, you're going to weigh this bag on the orange scale again. Make sure you're using the same scale. Make sure you're using the orange scale. And this time we get wow.
A different number.
We get a different number.
Typically, it's going to be higher.
Typically, it's going to be a little bit higher. Okay.
Do you want me to hold that down?
Yeah, look at that. We get a reading of approximately, it'll be just barely higher than what you would expect. So it'll be, for example, in this case, it's 27.85 grams.
Okay.
Okay. Now, once you've done all 3 trials, okay, with your last trial with your helium, what you're going to do is you're going to take your bag over to these troughs.
So we have already figured out then the mass, the weight of the 3 gases. So I do oxygen, carbon dioxide, then I'm doing helium. And so the oxygen, I'll weigh it, and once I'm done, then I squish it
Squish out all the oxygen.
all the oxygen. Carbon dioxide, weigh it, squish it all out. Helium, before I squish it all out, now you're going to tell me that we're going to figure out the volume that's inside this. And it'll be the same for each of the gases.
It should be an identical volume because we're using the same bag the whole time.
Okay.
So what we have here, now this is the fun part of the lab, believe it or not.
We get wet?
Oh yeah. See, this is the part of the lab where students often will have a little bit of difficulty. Okay, what we have here, this is a 2.5 liter jug basically. 2.5 liter jug. We have these cardboard tops for you to place over the jug. Okay, and this is a pneumatic trough. And inside the pneumatic trough, what you'll find is there is a hose that sticks out of the pneumatic trough and a drain on the other side. You want to make sure that this drain is over top of a sink in the middle of your bench or over top of a sink at the end of your bench. Otherwise, the water gets everywhere.
Or in the pocket of your neighbor.
Yeah, or in the pocket, exactly. That would be a funny
No,
trick.
no, don't do that.
Okay. So once you have it like this, make sure this again is above the level because otherwise the water will drain out. So I'm just going to stick this here for now.
Okay.
And what you're going to do is you're going to take this jug, okay? I always get a little nervous at this point.
This sounds quite fun. Do you want me to hold that?
Yeah, if you could just hold that up.
I'll hold this up.
And actually it is better to work in partners for this spot. And you're going to turn it over.
Turn it over, get it
Okay,
under the water.
Place it under the water and then remove the cardboard.
All right.
Notice how that's been done a few times before. Eh?
That's very good. And you didn't get any, hardly any bubbles in there?
No, hardly any bubbles at all. And I've
So
got a couple of air bubbles in there. If it's just a couple of air bubbles, don't worry about it. If you have very, very large air bubbles, then you should try it again. Refill the water. Make sure you get rid of all the air bubbles.
That'd be fun to take it back out.
Yeah, it's tough.
Oh, it will be good. All right. And then, so once it's in there, then what do you do?
Once it's in there, you're going to move it over so that it goes over top of where
this
the intake valve goes through into the pneumatic trough. Exactly.
Ah, I'm with you.
Okay. And so now that we've got that done, I'm going to get Jeff's going to take off this stopper.
And put it in there real quickly?
Well, just remember it's helium, so you're going to want to hold it up.
Up.
So
it won't come back down.
So it won't come back down.
All right.
Okay, and we're going to place it on the end of the pneumatic trough, or the intake valve, and then we're just going to give it a little squeeze.
Can I do it?
You go ahead, yep, sorry.
Is that okay?
Oh yeah, no problem.
I've been wanting to do this for a long time. Okay.
Okay, and you'll notice that the bubbles come in and they get caught in the large jug.
That's sort of fun. Oh, look at that one, eh? And now how much do I squeeze?
Just,
Probably want to get it all out,
Just
eh?
a consistent. Yeah, you want to make sure you get all of the air out, as much air as possible, or helium as possible, into the jar.
No, but I noticed we're supposed to be determining the volume of this thing, right? But there's no gray gradients there for me to determine that.
No, there's not. And this is where the fun part of this lab comes into play.
Okay, I am gasless in here.
You're gasless.
Yeah.
Okay. The next part of this lab always gives people some trick. It's a little bit tricky.
This is where you get wet?
This is where you get wet. What you want to do is you want to move this.
Oh, don't lift it up out of the water.
Don't lift it out of the water. You want to cap it with the cardboard.
Put the cardboard on.
And then you're going to pull it out and flip it back over again.
Oh, you didn't get wet at all, man.
I know.
That's no fun.
Not my
Can I
first
just
time.
flick you with water?
Thanks.
Okay.
Okay. So now we've got this on the counter. Now the way we're going to determine the volume of the gas that was in there.
So it would be from here to here, right?
Here to there. Yeah, perfect. Is you're going to take a 500 ml graduated cylinder from the back, and you're going to pour this in. Okay?
So you made sure that was 500 mils of water in there, right?
Exactly 500 mils.
So I'm going to pour this stuff in.
Pour
and
this in.
Wherever it stops, then I'm going to subtract. That'll be my volume. I'm with you.
Exactly.
So don't spill at this point.
No, you don't want to spill any of this, or else you have to start over again. So slowly but quickly pour this in. This isn't going to be enough.
I don't think it's going to be enough, man.
So
Not enough.
That's 500 mils.
So 500.
So we'll go grab some more.
Okay.
Sorry, I know talking off camera is not very
So
polite.
he was right about there. I think you're going to need at least another 500. Don't you have about 1,000 milliliter graduated cylinders?
We do. We have 1,000 mil grads.
Oh, but how much do they cost?
They're about $1 a milliliter. So that's again is exactly 500 mils.
So I'm at 500 so far. Okay.
We're going to add another 500.
Oh, I think you might have it on this one. Don't go over.
Until we
That's about perfect.
get it brimming again. And it looks like to me that's about 25 mils left in there. So we have a total of 975 mils of gas.
So that would be
The
how
vol-
much? Go
The
ahead.
volume of that bag was 975 milliliters.
All right. Almost a liter.
Almost a liter. Yep.
All right. Perfect. And so then I can do my calculations from that. Anything else that I need to do with this stuff?
No, all of this stuff can, obviously it was water, so it can go down the sink.
You look
And-
wet.
I am a little wet.
I wonder how that
I
happened.
don't know, it just happened. But the neat part about this is if you work in partners, now that you've filled this back up again, your partner can just recap the bottle, and away they go.
Away they go. But they're still doing their own.
Still doing
but
their own,
sort of
but
do
work
when
in
somebody
partners.
needs some help,
Help 'em
work in
out.
partners.
Yeah.
That's great. Anything else?
No, I think that's about it. For the most part, this is a fairly safe and fairly simple way to show relative mass of three gases.
Good. So we'll be comparing the three. In the calculations, we look at comparing the three different gases. But we've shown you now then how you can weigh a gas and how you can determine the volume of that gas. So good luck in the lab. We'll see you when you come.